Welcome to this explainer. You know, we hear AI buzzwords thrown around all the time, and honestly, it can feel like a chaotic mess of tech jargon. But today, we're going to take this massive ecosystem that we all use and map it out into a really cohesive, structured mental model. Let's dive right in and organize the complex landscape of artificial intelligence into a crystal clear framework.
Okay, so here is the complete artificial intelligence ecosystem map. Now, I know what you're thinking. It looks overwhelmingly complex at first glance, but promise me, you won't panic. Rather than looking at this as a tangled web, we're going to act as your guide and explore how this maps out incredibly logically. Think of this entire ecosystem like a highly organized factory pipeline, where every single piece has a specific place and purpose, literally from the core mathematical research all the way to the smart apps running on your phone right now.
Here's our game plan for today. First, mapping the AI universe. Then, core research and foundations. Third, building and tuning models. Fourth, platforms and ML ops. Fifth, smart applications and agents. And finally, governance, security, and regulation.
All right, part one, mapping the AI universe. To make this whole ecosystem super easy to digest, we're going to take an inside-out approach. But before a single piece of code ever enters the main factory floor, it starts right here in the agile lifecycle. It's like a testing ground. Ideas start out as just a concept. Then, teams go through rigorous data prep, they build a preliminary model, put it through heavy evaluation, and finally deploy it. It's this continuous loop where raw ideas get refined and stress-tested before they ever make it into the heavy-duty layers of the broader AI ecosystem. Moving right along to Section 2, Core Research and Foundations.
So once an idea finally makes it out of that agile testing loop, it enters the absolute center of our map. You can think of this as the foundational brain of the ecosystem. The actual bedrock of how machines learn to process raw data comes down to these core approaches. You've got supervised learning, which is basically teaching the AI using clearly labeled data. Then there's unsupervised learning, where we let the machine discover hidden patterns completely on its own. And finally, statistical machine learning, which is the underlying hardcore math that allows for probability-based predictions.
Now, stepping into the data and knowledge infrastructure layer, we hit something absolutely crucial: transformers. These are specific, highly advanced deep learning architectures that power large language models. They sit right alongside convolutional neural networks, which are used to process visual data, but transformers, they act as the critical infrastructure for processing massive amounts of sequential knowledge. Basically, they are the main engine block driving modern generative AI.
Which naturally brings us to a really interesting question. We have this raw, generalized foundational brain, right? So how do we actually fine-tune it to do highly specialized, incredibly complex jobs without breaking a sweat?
That brings us to Section 3, Building and Tuning Models. Welcome to the Model Development and Fine-Tuning layer. This is the customization shop. It's where developers take those massive, general-purpose models and tailor them for specific industries. A total game-changer in this layer is Retrieval Augmented Generation, or RAG for short. See, rather than just relying on whatever data the model was originally trained on, RAG actually goes out and retrieves external, up-to-date data right at the moment you ask it a question. This grounds the outputs in reality and massively reduces those weird AI hallucinations. It sits right alongside prompt engineering and knowledge engineering as a vital tool to just engineer way smarter outputs.
And developers have some pretty clever tricks to customize these models even further without messing up the underlying structure. They use specialized fine-tuning techniques like LoRa and PEFT. The big value proposition here, it's all about efficiency. Instead of blowing massive amounts of computing power and money trying to train a giant model from scratch, these techniques let you adapt large models by just tweaking a tiny fraction of the parameters. It saves so much time and compute cost, it's brilliant.
Let's zoom out to Section 4, Platforms and ML Ops.
Okay, so we've got our customized model, but now we need the heavy machinery to actually run this software at scale. This layer is an absolute powerhouse, fueled by massive GPU and TPU training clusters. If we trace the pipeline, models go into registry and deployment through continuous integration and continuous deployment pipelines, your standard CI/CD. From there, they move into model serving and inference. This right here, this is the precise layer where the real-time compute happens when a chatbot actually talks back to you. And finally, the system connects to tool orchestration, which is what allows the AI to take action and use different plugins.
So, let's recap for a second.
We've built this incredibly powerful AI engine, we fine-tuned it, we deployed it on these massive server clusters, but how do we actually put it to work in our daily lives? How do normal users interact with all this incredibly deep underlying infrastructure?
Here's where it gets really relatable. Section 5, Smart Applications and Agents. This is the consumer-facing front door of the factory. It's where AI is deployed to automate processes and solve real-world problems for us. Think about all those fascinating creation outputs you probably interact with every day. Speech interfaces, audio and music generation, video creation, image generation, and even code generation. All of these amazing tools are literally just the outermost layer, the tip of the iceberg, resting entirely on top of all that dense core research and MLOps infrastructure we just talked about.
But the focus in the industry is rapidly shifting. We're moving way past just using single, isolated AI tools and stepping into the era of autonomous, multi-agent systems and AI co-pilots. Thanks to really tight delegation and handoff protocols, we now have multiple AI agents that can actually collaborate with each other. They can double-check each other's work and automate wildly complex workflows entirely on their own, personalizing the whole experience directly for the user. It's pretty mind-blowing.
Which leads us to our final and arguably most important stop, Section 6, Governance, Security, and Regulation.
Look, when you have systems this powerful operating autonomously, you absolutely have to have strict factory safety standards in place to keep everything from going off the rails. The entire ecosystem has to be wrapped in key governance pillars. We're talking about bias and fairness auditing, strict accountability, and a really important one, explainable AI, or XAI. If an AI executes a critical, life-impacting decision, XAI ensures we can crack the black box open and see exactly why it made that specific choice. Ethical monitoring and global compliance aren't just nice-to-haves, they form a mandatory protective shell around the whole system.
And right alongside that governance, you need hard, robust security measures. This includes strict data privacy frameworks and adversarial protection. One of the most fascinating components here is red teaming. This is where highly specialized security experts actually play the bad guy. They intentionally attack the AI model in a controlled environment to hunt down vulnerabilities, ensuring the system stays completely robust against real-world malicious attacks.
So, bringing it all back together to look at the big picture one last time, it makes a whole lot more sense now, right? We've successfully built a clear, structured mental model of the entire pipeline. We can trace exactly how agile concepts turn into core math, how they get fine-tuned for specific jobs, deployed at scale via MLOps platforms, surfaced to us as smart, autonomous agents, and finally, secured by rock-solid governance and safety protocols.
But as we wrap up this explainer, I want to leave you with one lingering, super crucial thought. The core research at the very center of this ecosystem is evolving at an unprecedented, breakneck speed. As it continues to rapidly expand outward, creating more and more autonomous, multi-agent systems, will our human frameworks for accountability, explainability, and safety truly be able to keep pace? It's a massive, provocative question we all need to be considering as we navigate this AI revolution. Thank you so much for joining me today.